Welcome in the subject mechanical system design. Today we are going to discuss the important topic of our subject mechanical system design. That is nothing but a unit of design of cylinder and pressure vessel. In that we are going to use the different types of equations to check whether that design is safe or not. So first important equation is the Lami's equation, which is used to perform the design of the cylinder. So when the material for the cylinder is brittle, like a cast iron or a cast steel, the Lami's equation is used to determine the wall thickness. So there are two types of materials used to manufacture the cylinder. That is nothing but the brittle material is most commonly used or widely used for the making of the cylinders. So the cast iron is a brittle material or cast steel, it is also a brittle material. And whenever we are going to manufacture the cylinder or we want to make the cylinder, then we want to define or determine the wall thickness. So the Lami's equation plays an important role for the designing or determining that wall thickness. So in Lami's equation, it is based on the maximum principal stress theory of failure. When maximum principal stress is equated to or is equal to the permissible stress or allowable stress for the material. Okay, so here by using the maximum principal stress theory, what we are going to calculate? We are going to calculate the actual stress required for the design of the cylinder. That value should not be greater than the allowable or permissible stress value. So the Lami's equation gives us that value. So we can predict whether that design is going to safe or not for the cylinder. So here the basic consideration for the Lami's equation is first three types of stresses are we are going to calculate. So first is a tangential stress, second one is a longitudinal stress, and third one is a radial stress. So here we are going to consider the radial stress equal to the internal pressure acting inside the cylinder with the negative sign or negative parameter. Then tangential stress we are calculated by using same method as already discussed in the previous topic. That is nothing but the tangential or hook stress, or it is also the stress acting along the circumferential region for the cylinder. So that will be equal to the positive pi do square plus di square upon the difference between the square of diameters for the outside diameter of the cylinder and inside diameter of the cylinder. So where here it is a pi is the internal pressure acting inside the cylinder in Newton per mm square. DO is the diameter, outside diameter of the cylinder in mm. DI is the inner diameter of the cylinder in mm. So by using that, this formula we will get the circumferential stress or hook stress or tangential stress for the cylinder, which is made up of a brittle material. Then also longitudinal stress we will get as a pi di square upon difference of outside diameter to the inside diameter. So pi is the here inner pressure, di is the inner diameter of the cylinder, do is the outside diameter of the cylinder, and sigma l is the longitudinal stress acting on the cylinder. So in this way we can get the three types of stresses acting on the cylinder using the same method already discussed in the previous session for the calculation of the different stresses values for the cylinder. Then by Lami's equation we will get the thickness of the cylinder is equal to di by 2 into bracket square root of sigma t plus pi upon sigma t minus pi minus 1. So here in this equation where t is the required wall thickness for the material, then di will be the inner diameter of the cylinder, sigma t will be the circumferential stress, and pi is the inner diameter of the pi is the internal pressure of the cylinder. So here you can observe we are going to neglect the radial stress at that value is very less, and also we are going to neglect the Lami's equation So by using this equation, we will get the uh, we can calculate the thickness of the cylinder. Then another formula to get the or to compare the calculated stress with the permissible stress, we are going to use this second equation as a sigma t is equal to SUT upon factor of safety. So ultimate stress we know that is nothing but a permissible stress value we know, and factor of safety also we are going to know. So the we can also calculate the tangential stress and compare with the permissible stress, so that our design is safe or not, that we are going to predict. Next equation is a Clarineus equation and Bernoulli's equations. So when the material of the cylinder is ductile, such as a mild steel or alloy steel, maximum strength theory for failure is used as a creation to indicate the failure. So according to this theory, the material begins to yield or begins to fail when the maximum strain at the point equals to the yield point strain in the simple tension test. So here in previous equation, if is suitable for the brittle material, and this Clarineus and Bernoulli's equations are suitable for the ductile material. So again here we are considering the three stresses: radial stress, tangential stress, and longitudinal stress. Same formulas are there in like previous case, but here strain is calculated equal to the uh, 1 upon E into sigma t minus mu into sigma r plus sigma L. So here strain is calculated by using this formula. Then thickness is calculated by using this formula: di by 2 into bracket square root of sigma plus 1 minus 2 mu pi divided by sigma minus 1 plus mu pi minus 1. So this equation is known as a Clarineus equation. By using this, we can calculate the thickness of the cylinder. Then we calculate the stress by using the SUT upon factor of safety and compare it with the allowable stress or permissible stress, and we are predict that whether our design is safe or not. So this is the suitable Bernoulli's equation or Clarineus equation to calculate the thickness of the cylinder for the ductile material. Next equation is a Bernoulli's equation. So when cylinder ends are open, then this equation is used to calculate the thickness of the cylinder. And whenever the cylinder are closed, then the previous equation, that is a Clarineus equation, is used to calculate the thickness of the cylinder. So when the cylinder ends are open, then the longitudinal stress will be equal to 0, and circumferential stress we are calculated by using this formula. So the final thickness of the cylinder is equal to di by t, square root of sigma plus 1 minus mu pi divided by sigma minus 1 minus mu into pi minus 1. So in this way we can calculate the thickness of the cylinder when the cylinder's ends are open. So this equation is also called as a Bernoulli's equation to calculate the cylinder thickness for ends are open. So thank you for watching the uh, this topic, that is a different equation for the design of the cylinder.